So I use a range of different methodologies in the field, studying mangroves and salt marshes and casuarinas. Some of those go from really manual measurement techniques, looking at the mangrove biomass, doing measurements of how tall a mangrove is, how wide it is, taking soil cores, analysing those back in the lab. But we also use some technology. It's a great time to be alive in terms of wetland science. We've got things like water level loggers, which do a lot of the data collection for us. So rather than being here and taking a measurement of how deep the water is in the creek behind us, we can deploy one of these loggers. Every 15 minutes it will take a measurement of the water level. So I can go off, do some other work, do some other research, come back in a month's time, download this onto the computer, and I've got the data that I need there. Another thing that I use here is a fancy GPS. This is called a real-time kinetic GPS. So this is operating just like the GPS in your phone. This thing up here is talking to satellites. It's talking to lots of satellites that are going around the world at the moment, but it's also talking to the phone network. And that means that unlike your phone GPS, which gets accuracy within maybe 5 or 6 meters, this thing here can get accurate readings to within 1 or 2 centimeters. So when we're working in wetlands that are facing sea level rise, 1 or 2 centimeters is critical. So we can know at what elevation the mangroves are growing, at what elevation salt marsh and casuarina are growing, and we can project what an increase of 1 or 2 or 3 or 4 or 20 centimetres in sea level might mean for those communities. So critical piece of information and equipment here.